Design of electric cycle, complete design and analysis of two electric cycles models. Abstract. The research paper revolves around the concept of electric cycle and how to make it as cheap as possible, adding only necessary electronics in the circuit. Our aim was to create a working prototype which can compete in the e-cycle market on efficiency as well as in price. Two e-cycle models are present in this research paper. One contains lead-acid battery pack and other contains Li-ion battery pack. This is done to create a comparison between both packs and arrive at a conclusion. Keywords: battery management system, lead-acid, Li-ion, parallel, series. Introduction. The research paper contains complete design and creation of two e-cycle models, one with lead-acid battery pack and other with Li-ion battery, for factory workers as well as lower middle class. To do that we need to physically test and conclude which type and arrangement is best for our cycle for our requirements. By the end of this paper, there would be conclusion regarding the type, arrangement, and battery type of this electric cycle. 2. Need for such analysis. The need for such analysis is very much evident once we look at our heavy dependence on fossil fuels and pollution that conventional vehicle causes. 2. The cycle contains a certain particular objective, that is to be as cheap as possible, as the cycle's targeted customers are the daily wage and industry workers who cannot afford a 20,000 worth electric cycle. This cycle being cheap will help them in travel and transport without using much for their time, energy, and money. Our main focus is to make it appealing to these workers as well as lower middle class. To do that we need to physically test and conclude which type and arrangement is best for our cycle for our requirements. By the end of this paper, there would be conclusion regarding the type, arrangement, and battery type of this electric cycle pack. The two models will have different arrangements and specifications. These specifications will be used to derive a conclusion for electric cycle solutions for daily wage workers and lower middle class people. This comparison to conclude contains various parameters such as cost, design, aesthetics, efficiency, safety. 3. Cycle components. 1. DC motor 24V250W. 2. Lead acid, 26V18AH. 3. Freewheel, 18 teeth. 4. Sprocket, 9 teeth. 5. Switch. 6. Complete circuit formation. 7. Battery charger 44V4.2 a constant charge. 8. Li-ion batteries, 60 cells. 9. Li-ion battery management system, 2*3s. 10. Lead acid battery charger 45V5 a constant charge. 11. Wires for connection. 12. RXTX connector. 13. Battery indicator, 12V. 14. Li-ion battery management system, SIXS. 15. Cycle chain. 16. 1.5 x 2.5 feet 3 mm thick steel sheet. 17. 1 x 1 foot 1 mm thick steel sheet. 18. Spray paint. 19. Soldering iron. 4. Using the template. The prototype 1 contains lead-acid battery pack. This battery pack is of good quality, contains 1-year warranty and has good life cycle. The battery pack contains 2 lead-acid batteries of 18Ah and 12V connected in series to get a pack of 24V and 18Ah56. The prototype specifications, 5. 1. Range equals 40 km, verified by Google Fit. 2. Max speed equals 22 km/h. 3. Battery charging time equals 2 hrs. 4. Battery capacity equals 18 Ah. 5. Battery voltage equals 25.5 V. 6. Motor voltage equals 24 V. 7. Motor power equals 250 W. 8. Sprocket reduction equals 1:2. The picture of the prototype 1 is given below. 6. Battery management system. The Li-ion cells or battery pack of such cell require a battery management system while charging, discharging, and normal operation. This BMS is very important part of a battery pack. It helps the battery pack to increase its life and also prevents overcharging and deep discharge. The overcharging is prevented by the BMS by absorbing the extra charge to a certain limit which is specified in its manual, after which it gets shot and breaks the circuit. Even if the circuit remains after the BMS shorting, the sound and smoke of shorting act as signal to the user that overcharging is happening and charging need to be stopped. Deep discharge happens when the battery pack's terminals get connected by some mistake. In such case also the BMS behaves similarly as it behaved in case of overcharging. It basically acts like a protective circuit. During normal operation, the BMS redistribute the voltage coming from each battery in such a way that the charge depletion happen equally in all cells and thus improving the life of the battery pack. 2.3.8. Prototype 2. The second prototype contains the above battery pack and has different body design to accommodate ease and comfort of use as factors for selection. Due to small size of Li-ion packs, they are easy to mount. The pack uses the Li-ion cells from a local vendor, thus quality is big question. The cells from a good quality authorized vendor will make the pack out of budget, and this prototype model will get rejected on the basis of cost. The Li-ion cells are more efficient than lead acid but of same quality level. 11. Final conclusion. As discussed and compared earlier, we conclude that prototype 1 must be considered for creation of a model. Current Li-ion pack is much less efficient than the lead acid pack due to quality difference, but prototype 1 body design is not ideal. Its body design needs to change. For that we have considered deriving a design from prototype 2 body. 12. Battery box design. As we can observe that a new component is added in the desired final layout, that is a battery box, so we need to design a battery box according to the given specifications for the electric cycle. The battery box mount has 3 important parts. This part will be exact opposite to PART1. It will be a rectangular base welded to the base of battery box from middle and its end hinged in upward direction. This part will be free to move from end but welded from middle. The hinged ends will contain 2 4mm holes matching PART1. The battery box will have 2 bolts on each sides with 4mm diameter welded to it. The holes from PART1 must match to these bolts such that the ends can be folded into these bolts. Final part. Finally, the third part is the assembly. The assembly of these parts will be relatively easier to understand and perform. PART1 is attached to the carrier and PART2 is attached to box both and the middle. Both these parts have hinged, free to move ends. These ends have matching holes of 4mm which also match to a 4mm bolt. Both the ends are kept at the middle position and are just bolted together using 2 4mm bolts at each side. Since the battery box is welded to middle of PART2, it also gets attached but using bolts. This ensures that box is detachable. When box is detached, the PART1 ends go downwards and hence will not harm or create any problems for the rider. PART2 ends can be again folded into 4mm bolts of battery box as seen in PART2 diagram. Here is a diagram, depicting the final assembly. 13. Final conclusion based on cost. Cost is big factor in this research project. Our aim in this paper is to provide a cheaper solution for the 20,000 rupees e-cycle available in the market by removing or replacing some features of less importance but providing similar efficiency. The efficiency part has been achieved by our final model, and this section shows how much the cost was reduced. Total cost with 10% GST equals Rs 0.12155/. Price reduction percentage equals 20,000 to 12,155, asterisk 100/20,000 equals 40%. We can observe that in the final model the price was reduced by 40% of the market price for similar performance parameters. Hence, we can conclude that the final model satisfies our research purpose by all the standards, cost, technical as well as aesthetics. 14. Acknowledgement. 1. We wish to express our gratitude to Professor, Drive, Rajesh M. Jalnekar, Director, Vishvakarma Institute of Technology, PUN, for providing the facilities of the institute and for his encouragement during the course of this pandemic period for this research paper. 2. We also want to express our deepest gratitude to Professor Drive Mainshpi Chaudhary, Head of Mechanical Engineering Department, Vishvakarma Institute of Technology, PUN, for his guidance and support.